So this is a projectile motion problem. Projectile motion problems usually have to do with throwing something up in the air, and gravity's going to take over, and it's going to, come back down to the ground. Maybe you're shooting an arrow or hitting a baseball or something like that. We have a formula based on velocity and how high off the ground you are when you shoot the arrow or throw the ball or whatever, and you get a formula. Now they give it this to us. And if you're going to take physics, some of you will take physics, you'll do some more problems with this type of thing. Okay, so it says a ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation, and then they give us this equation. So here's what's happening. Here's a building. We're standing on top of the building. My little guys always have a hat. And we're going to throw this ball up in the air. The ball's going to go up, and then eventually it's going to start falling down to the ground, right? Okay. So right here, the ball starts out 40 feet off the ground. All right, and then because we're throwing it up into the air, it's going to reach a point up here, and then gravity is going to take over, and it's going to start coming back down to the ground, and eventually, here's the grass on the ground, it'll hit the ground. Okay, so that's what's going on in the problem. Our first question says, when does the ball reach the maximum height? Now, you can see the formula is quadratic. You can also see by my diagram, it kind of makes a parabola, right? Okay, so maximum, whenever it says minimum or maximum on a quadratic equation, we're looking for that vertex. Okay, so one thing we could do with this formula, h of t, no we can't. Okay, we'll just copy it down. Negative 16t squared plus 80t plus 40. I was thinking, 16 goes into all of them, but 16 doesn't go into 40. So, okay. Well, we want to find the vertex. So let's find h, for the vertex. H is going to be the opposite of b over 2a. So in our case, the opposite of 80 over 2 times negative 16. Now, I believe 16 goes into 85 times. So I'm going to simplify this to be 5 over 2. Yeah, it goes in 5 times. Okay. Then to find k, that's going to equal capital H of 5 over 2. And so that's going to equal negative 16, 5 over 2 squared, plus 80 times 5 over 2, plus 40. Okay, and then I'm just going to work with the fractions. Negative 16 times 25 over 4, plus 40 times 5, plus 40. So what do I get? 4 goes into 16 4 times. That's going to be minus 100, plus 200, plus 40. So I'm going to say that's going to be 140. Now, what are we finding? Well, it's a good time to think about that. So let's go back to our diagram. Remember, we were throwing the ball at 0 seconds. It's in our hand. And then we throw it. We count 1001, 1002, 1003. I don't know how long it's going to take, but it's going to go up in the air, and then eventually it's going to, over time, it's going to come back down to the ground. So it's a function of time, t for time, and that time is in seconds. Okay? Now when we found the vertex here, that maximum there, it turned out to be the point 5 over 2, or you could write that as 2.5 if you want a decimal. More of a fraction fan myself, but that's okay. What does that tell us? It tells us it's taking 2.5 seconds. I just switched to the decimal. Okay, so 2.5 seconds. That makes a little more sense to talk that way. This is the seconds to reach that maximum height. So it says, when does the ball reach the maximum height? So question A, after 2.5 seconds. That's when it's going to reach the maximum height. B, what is the maximum height? Well, we already figured that out. It's 140. 140 feet is the highest it's going to be off the ground, and then it's going to start coming back down. Okay, and then we have a question C. When does the ball hit the ground? So you have to think about the ball being here on the ground. When does that happen? Well, or how long does it take, for the ball to hit the ground? So what we're saying is, when is it 0 feet off the ground? When is the height 0? So we're going to take, for part C, we're going to take that function and set it to 0. When does that equal 0? Well, I could write my function in standard form. Remember we did that before? Let me go over here and do that. So we already know the h and the k, right? This was h, this was k, and a was negative 16. So if I want to write that function in standard form, it would look like this. There it is in standard form. Now, it might be easier if I take that and set it equal to 0. So let's see. Negative 16 x minus 5 over 2 squared plus 140 equals 0. Now you might be saying, well, why didn't you use the quadratic formula? You could. You could take this and use the quadratic formula. I was just thinking the numbers were a little big and that maybe it would be easier if I did it this way. We'll see. Either way, we should get the same answer. Okay, so negative 16 x minus 5 over 2 squared equals negative 140. I'm going to divide both sides by negative 16. And let me see. Divide by negative 16. So I get x minus 5 over 2 squared equals, and then I was thinking it was going to work out, but let me get a calculator in. Well, it didn't work out as nicely as I was hoping. It winds up being 8.75. And then I'm going to have to take the square root of that. I'm going to switch to decimals now. Now I put the plus or minus because we were taking, sorry, technical glitch. So I put the plus or minus because we were taking the square root of both sides. But really, our answer is seconds. And actually, these should all be t's and not x's. I don't know why I did that, but my guess is that we're not going to be able to have the minus case because we're not going to have negative seconds. You're not going to go back in time. So I have to figure out then what's the square root of 8.75. And I don't have my good calculator. I'm using my phone. Oops. And it gets to be about 2.95. So 2.5 plus or minus approximately 2.96 if I round it off. Okay, now I know it's not the minus case because that would give me a negative number, but we'll come back and talk about that a little bit later. So let me add the 2.5, and it's going to be about approximately 5.46 seconds. So we were standing on top of the building, and we threw the ball up in the air, and eventually it hit the ground after about 5.46 seconds. Now, let me just say whoops, sorry about that. Let me say one thing back on our picture. Remember there was that minus case, and I said, well, we're not going to go back in time, so we're going to throw that one out. But if you were to follow the parabola, you know, back in time, think about it over here. See, you would get another intercept, but it's going to be negative, you know, so negative amount of time. Right here, the ball is at 0 seconds. Okay, so you can think about that later if you want to. And I think we got a final answer here. Oops, for part C, about 5, and that's an approximation sign, about 5.46 seconds, and the ball will hit the ground.